Hello and welcome to this video on data science and big data. Two topics that are practically inseparable in the modern world and of an ever-increasing importance. For this video, we're going to turn the usual process of explaining things and then giving you an example first on its head. If you use an Android phone, iPhone, social media, Chrome web browser, shop through Amazon, and more, you are providing more data than you realize to one or more companies. It could be your browsing habits, that you stalk an ex on Facebook at 3 AM on Saturday. You buy an oversized self-pleasure device, cat food and wine regularly, and more. Each of these is a small point of information that can be gathered about you. Remember that if you are not paying for a service, then someone else is, which means that you are not the customer but the goods. All that information that you have given over to these companies collectively is by itself almost without any value. The average person's data is worth about 10 cents to a company like Facebook each year. It is when you start to pile it together with hundreds, thousands, and millions of other people's data that you start going somewhere. This phenomena is best typified by one high-profile case study. The Target pregnancy scandal. This was in very brief a situation in which Target identified a series of shopping behaviors that indicated women were pregnant. Lotions, soap, and more. It used both their shopping behavior and baby shower registry data to further corroborate the initial findings. They were then able to start targeting people with specific advertisements, coupons, and discounts suited to pregnancy before they gave birth. This was to create a customer base that was loyal to Target. The scandal part of this comes from a teen who was pregnant, and the advertising was received at her home where she lived with her family. Her father thought that sending pregnancy-related advertisements to a teen was inappropriate, thinking it might encourage pregnancy. They then complained to the manager. This went up the food chain to corporate headquarters. Corporate then explained to the manager, who then explained to the father, that the material was sent to the teen as they thought she might be interested, and that they were very apologetic. The catch to this was that the teen was pregnant. The father just didn't know yet, but Target certainly did. Talk about a poor start to that conversation. This is the gist of both big data and data science in a way. It is the means of gathering, cataloging, and passing information on a previously unknown scale to identify patterns which can be used for good, bad, and neutral reasons. Data science is how this process happens, and data scientists are the people that do it. Big data has no definitive definition as such. It is generally accepted to mean extremely large data that can be analyzed with computers, which then in turn reveals patterns, trends, and associations. As we've mentioned already, this could be a whole range of things. One of the characteristics of this is that it is also generated at an incredible speed, in a wide variety of formats, contexts, types of data, and it nearly always has some kind of relationship to other big data. It includes, but by no means is limited to, genetic data, shopping data, travel, social networking information, demographics data, epidemiology, insurance claims, and the list just goes on. These collections are not small. We're not talking something that you could readily fit on a home-based computer. Even some large businesses would struggle to store this information. We are talking about terabytes on top of terabytes. Some go into the range of petabytes and then even larger again. This is one reason why most data like this is held proprietary by companies. Think of what Amazon gains from holding onto all that information about what you buy, when you buy it, and in what situations you buy certain products. The same thing goes for Google. Where are you? What are you doing? How often do you go to that place? They can find this all out using your phone and some of the features on it. What about contents of your email? Search items in the browser? So on and so forth. Everything can be used to both empower their advertising arm, but also to better advertise to you. Such monstrous amounts of data need special skills to be analyzed. This is where data science comes in. Data science is the bastard love child of statistics and programming. It often relies heavily on classical statistics approaches such as correlation, probabilities, and more. The problem is that classical statistics packages, such as SAS, SPSS, and more, which lacked the flexibility in the early days to meet data science needs, are, while now catching up, not as popular for that reason, at least in the early days. This is where programming came in. If you could program the right equations, processes, and more into something like Python, C, and other languages, you could achieve similar results to the statistics software. You could take a more flexible approach and get more useful data in less time from a wider body of information. Eventually, software packages started to catch up, but the current frontrunner, in our opinion, remains the free open source R. R is a programming language, software, and interface. It is the 9th most common programming language. Among the way data science is used is the development of machine learning and a sort of rudimentary AI. Both of these approaches have their own strengths and weaknesses, which we'll go over in a very cursory manner. Be aware that some of these concepts can take both an entire semester at university and often several semesters where you gain a greater knowledge of what's happening. We will provide you with just the smallest amount of information to begin figuring out what's happening. Machine learning is, as the name suggests, the process of developing code that can refine its own effectiveness over time. This is within a narrow scope, but is easier to make and achieve than an AI. The way machine learning works is to take two sets of data. One is the data you use to establish relationships, calculations, probabilities, and so on. This is also the data you run your initial testing on. Remember, this is separate data from the rest of the data used later. The process used should be able to be automated once you're done. That is run independently of human oversight, but before that, the machine is still learning, so that does not happen with the first data set. At this point, you will need to adjust the code, correct errors in the process, and more. That is exactly what this first dataset is for, beyond establishing the baseline of what you're trying to find in the end. It tells you what your machine needs to start working towards as far as its reliability and effectiveness. It's learning how to get certain results, specifically probabilities and accurate models of what's going to happen, given an array of variables in that dataset. Thinking back on that target case study, what they knew was that pregnant women were buying lotions, soap, and more. There was also a series of factors that could confound this for people who had infections. They were able to eventually figure out what factors went in what order and how, and what weight to give them in order to figure out if they were pregnant, or more reliably, give them a pregnancy score. That score was not a perfect predictor of pregnancy, but it gave them enough of an idea as to whether or not there was value in sending targeted advertising. That's what their machine learned how to do in that first stage. What factors and how much weight to give them to send out targeted advertising. Once you know how to pass the data to produce results reliably and consistency, you can take your dataset, and here is where it gets interesting for you. Your second dataset should have the same broad profile as your first. Now you set your machine to run and learn, as it knows the data should fall into certain categories and get certain results. If this is not happening, then the code alters itself to better align with the predicted outcomes. For example, the machine may have learnt to associate the same variables with pregnancy as with infection, but over time it would figure out that there was this small subset that had its own extra variables that once you added those into the calculation could be removed from the pool of people who might be pregnant. This process is not just applicable to marketing. It is especially useful in image identification programs. Do you need to pick someone out of a crowd, differentiate between a banana and apple, read license plates, identify fraudulent images in scientific publications? All of these are applications for machine learning. If you want an example of this, look to Spotify, which takes your current history and then suggests new options based on what it predicts you will like. AI is where data science starts to become murky. AI takes machine learning, where it is trying to be a better predictor of a given outcome, and begins to make decisions based on those models. It is a wider umbrella, and we call it a wider umbrella under which machine learning sits because an AI can reapply the machine learning systems, work through them in a series of parallel, complicated and interrelated phenomena to reach decisions, where machine learning can really only stick in its own lane and do one thing. AI is iterative and more comprehensive than machine learning in that respect. Think of how many companies currently use a chatbot on their website. This is a sort of rudimentary AI. We say rudimentary so often because these are not true AI. They still need to be programmed and are unable to operate independently of the program's instructions in any way, shape or form that goes beyond a very narrow envelope. They have a narrow scope of action, but they can perform in that action incredibly well and with surprising flexibility. Try entering gibberish into the chatbot's window. It may still try and suggest what you're after as it tries to figure out just what you're getting at. You could try writing in other languages, and more. All these things the AI, such as it is, can begin to figure out what it is you're doing, because not only does it learn, which it may not have access to another language in its training set if we're talking about machine learning, but as an AI, it can look at it and go, okay, it doesn't fit into English. Does it fit into Spanish? Or is there another dialect again? The AI can work far more flexibly than the machine learning can, but it's also a lot more resource intensive and more difficult to set up. There is one exception to the general data collection process we've described. This is Europe's General Data Protection Regulations, the GDPR. This niche piece of legislation gives Europeans some more protection from data mining by data scientists than other regions. Data mining being the process of extracting and then analyzing this data. So now you know something, even if it is something very limited, about big data and data science. You probably have an even healthier degree of skepticism about many of the free online services. While it is only a summary of these two particular points, it's something that over time will become more and more relevant to you and others as it finds a more pervasive role in everyday life. It's also an industry that is gaining more and more recognition as a necessity. Data scientists are considered some of the most in-demand people in any industry in the world at the moment, and that's because their skill sets are so desirable. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you might have below.